Welcome to our Occupational Health and Safety tutorial, Module 8, and today we're going to talk about workplace hazards and risk control. So we'll start with welfare facilities, the work environment. Welfare facilities are what we need as human beings to be able to do our work. And it's the basic things like sanitary conveniences, which means toilets. We need somewhere to wash our hands. We need somewhere where we can get a drink of water. Cool water in a warm country, hot water in a cold country. We need changing rooms. If we arrive at work in home clothes and need to change for work clothes, we need a changing room and lockers, somewhere to put our home clothes whilst we do our work. We will want a lunch break or a mid-morning break, and we need somewhere to sit and have that, or we need, and we will need with it perhaps somewhere to boil a kettle or microwave some food. We'll need seating, and not just a bench, but chairs with a back support so that we can rest and recover. We need ventilation. We like the room to have fresh air in it, so we need ventilation arranged. And then the room will need heating and lighting if it's a cold country, or it'll need cooling and lighting if it's a warm country. So we need those things. So we need to be particular and specific about the details of what we need inside our welfare facilities. So you want a toilet? Great. It should flush. You want to wash your hands? You will need soap. You will need water. You'll need some way to dry your hands, like a towel or paper towels or a hand dryer, electrical hand dryer. You want to heat food? You need a microwave. You want to sit and eat? You need a table and a chair with the back support that I mentioned. The amount or the number of toilets we need will depend on how many staff we have or people who will use the toilet. So if you have 5 in your office, you might have 1 toilet and that will be enough. If you have 50, 1 will not be enough. We might have different groups of people using the toilets. By this I mean you might have office people and you might have workers who are still in their work clothes when they go to the toilet. So you might end up with 2 sets of toilets. You might want to separate your male toilets from your female toilets. That's fine. Then you'll need 2 sets of toilets. And enough male toilets for the men and enough female toilets for the women. Then you need toilets in suitable places. So if it's a big factory, all the toilets in the office is not good, because the people who work in the factory at the far end will have to walk a long way to the toilet. So maybe you need toilets at different places through the work complex. And then all toilets need cleaning. They need maintenance. They need looking after. And so you need a cleaning arrangement to look after your toilets and keep them clean. Well as that, you will need some way to get people out in an emergency. So we can talk later about emergency plans, but the plan will include checking that people can get out of their toilets to escape, and that they have done. Lighting I've mentioned. We like to be able to see what we're doing in a toilet. Ventilation, we want some fresh air in the toilet. The floor condition. If the floor is slippery, that's not good. If the floor is dirty, that's probably worse. So the cleaning and the floor condition are important. We'd like the floor to be dry and clean. And then security. When we go to the toilet, we like to go in by ourselves and lock the door and know that we will not be disturbed while we're in the toilet. These things need to be part of our arrangements. We'll move on now to think about extremes of temperature. So it can either be too hot or too cold. You can be too hot outdoors in the Oman summer, for example. You can be too hot indoors in a foundry or somewhere where they heat metal. You can be too cold outdoors, like Jabal Al-Aqsa in the winter, or the UK in the winter. Or you can be too cold indoors inside a fridge. And that picture nearest me is the one of a fridge. Someone's inside the fridge moving stored materials. So we need to think about how to manage people in these conditions. So if it's hot, we have a natural mechanism for controlling our body temperature, and that's sweating. When we sweat, the sweat comes out to the skin and it evaporates. When it's evaporating, it takes heat from our body, which cools us. So sweating is a great mechanism for cooling us. But for the sweating mechanism to work, we need to have water. So if we don't have water, we're dehydrated. So solution for dehydration, drink lots of water. If we were to keep going, working in the heat without water, we'd start to feel dizzy, and then maybe we'd even faint. And if that continues and is worse, we'll end up with heat stroke as well, and ultimately death. So how to control this? Start at the top. Make sure that you can continue to sweat and you have enough water, you're drinking enough. If you start to feel dizzy, find somewhere to sit. Somewhere to sit that's cool, ideally shaded, and ideally with an air conditioner. So these are things that we can do to control our environment when we're working and when it's hot. Give people lots of rests and breaks. If you're working outdoors continuously in the sun, you know it's going to be hard on your body. Other extreme, it can be very cold. When we're cold, our body loses heat. What the body does, though, is keep the core organs, the brain and the heart and lungs, warm. And it does that by taking blood from the fingers and from the nose and the ears and your toes. So there's no blood there, they're going to get cold. There's nothing warming it. So if you keep working in this cold environment, you can end up with what we call hypothermia. You've got too cold. If the hypothermia is severe, that can lead to frostbite. If this gets, let's take my finger as an example, if it gets so cold that it freezes, then it could be damaged and even fall off, and potentially I will get gangrene. It will go bad when it thaws up. So the places where we're going to feel it are ears, nose, fingers and toes on our feet. That will also getting too cold will put strain on our heart, and it will reduce our immune response. We're more likely to get sick in these conditions. So what can you do about them? So similarly to for hot environments, instead of going to a cool place, if you're cold, you go to a warm room. Instead of having a cool drink, you have a hot drink. You stay in a warm room with your warm clothes on until you feel warm again, all through, including your nose, ears, fingers and toes. And then you'll be warm again and able to go out. But you must limit the period you're outside for, otherwise you will get hypothermia. We'll think now about movement of people, hazards and controls. What can we do? Well, the most common hazard for us in moving around are slips, trips and falls. And I'll show you a graph later with some numbers on it. But the thing to remember is we can slip if the floor is slippery. The floor might be slippery with dust or water or oil or some other material. If the housekeeping is bad, in other words there's rubbish on the floor, we can slip on and trip on those things. If we slip or trip, we can fall. Another thing that can happen to us is we can fall. We can fall from height. So it's obvious we can fall from height. If we're up, we can fall down. But even at ground level, we can fall down into a hole or into a manhole. So falls from height can happen at ground level, down, as well as from a high level to ground level. Where we have movements of people, we have the potential also for movements with vehicles, and where there's vehicles and people, there's potential for people to be hit by the vehicles. Things can fall on us. If it's windy, things can blow in the wind and fall off and fall on us. If we're loading a vehicle, something could fall from the vehicle onto us. So falling objects are something we need to think about as well. And then, if we're moving, we can also walk into things, particularly if the lighting is not good. So what controls can we have? For slips and trips, we can do good housekeeping, good lighting, clean the floors. For falls from height, we can put edge protection around so people cannot fall. For collisions with moving vehicles, we can separate people and vehicles. For falling objects, we can have good housekeeping, And for striking against fixed objects, we can provide good lighting and clear walkways so we can walk and walk safely. Collision with moving vehicles. The key thing is to separate people and pedestrians. People and vehicles. So, if there's no separation, we're at risk. The control is to separate people and vehicles. If there's bad lighting, we're more likely not to be seen by the driver as a pedestrian. So the control is provide good lighting. A blind corner is where you need to make a turn, but you can't see round the corner when you make the turn. So provide a mirror, so people can look in the mirror and see if anything's coming before they make the turn. Lack of warning signs and barriers. If you're doing a job, put a barrier up round it so people can see, in this area there's people working maybe overhead. This is a place where I shouldn't go, something might fall. So provide signs and barriers. Poor housekeeping. If you put things in the way, people will have to walk round them or drive round them, and they'll make sudden manoeuvres that other people are not expecting. So provide good housekeeping. Organise your warehouse tidily so that the route for the forklift truck is clear and the route for the pedestrian also clear, and they're both separate. Poor maintenance. If the brakes in your forklift truck are not good, it's going to be more dangerous for the people in the warehouse. So maintain your vehicles. So we've talked about segregating pedestrians and vehicles. Great. We can provide slip-resistant surfaces. So if the floor is slippery, like this one is, not suitable for a warehouse. Warehouse floors need to have a slip-resistant surface so that the people can walk safely and so the vehicles can stop quickly. We need to control spillages. So if somebody spills a liquid, we need to put a sign up and then tidy up quickly. Control the spills. And drainage, we're not so much a problem in Oman, but in the UK it rains a lot, so we need to make sure our rainwater drains away quickly. And if there's a problem in one area because of poor drainage, we can put barriers up and not use that area. Designated walkways. These are walkways only for vehicles and separate walkways only for people, and they're separate. Now we've separated people and vehicles, we should be in a safer environment. You can provide fencing and guarding. So if this is the forklift truck route, we can have a fence or a barrier or a handrail along here so that the vehicles and the people are separate. We can put signage up. Signage says things like speed limit 10 kilometers an hour, or it might say caution, people crossing at this point. And that will inform the drivers how to drive safely in that environment. PPE. PPE is a good last resort, so if it's a warehouse, let everybody wear a yellow reflective vest so that the drivers can see them clearly. Yellow vest. I can see him a long way off and slow down and drive carefully round him. And then IITS stands for Information, Instruction, Training and Supervision. All these are good things. So we inform people about the risks so that they're aware. We instruct them, do these things so that you stay safe. We can train them, this is the safe place to walk, this is not a safe place to walk. And then we supervise them to make sure that they're following what we've said. Working at height. Now this is the single most common cause of deaths in the workplace. So we need to think about work at height carefully. So we can fall from height over an edge. We can fall from the ground level into a hole, like an excavation or a manhole or a pit. We can fall from fragile roofs. You might have seen profile metal roofs or cement profile roofs. These can deteriorate over time and not be strong enough to walk on. So if you have a roof like that, don't let people walk on them. Provide signage that says don't walk on the roof. And if you have to go on the roof to maintain some equipment, install a walkway, a safe walkway with a handrail so they can walk to that place to do the maintenance, and provide a maintenance platform round the piece of equipment that needs servicing. So falls from height. The other one is falling objects. Now, things can fall because the wind has blown them, or they might fall because we have some rubbish, and the easiest way to get it down to the ground level is to throw it out the window. This is not good practice. We can provide a chute so that the material that we want to throw down to the ground slides down the chute and it can't fall onto anybody else. If it's windy, you're more likely to fall from height because you could be blown. If it's snow or ice, you're more likely to slip near the edge and go over the edge. So again, increased risk. And in Oman, if it's dusty or there's a strong wind, again, the dust can make it easier to slip. So falls from height need to be thought about. Here's the diagram that I wanted to show you. So for fatal injuries, we're talking about people being killed here. You can see there's trapping, struck by objects, struck by vehicle machinery, and then falls from height is the second from bottom one, which is a big one, and then all other causes is the biggest, but that's lots of things added together. So the biggest single factor for fatal injuries at work is falls from height, which is why we take such a keen interest in it. And for major injuries, we have a long list of things, but the biggest one is at the bottom, and the bottom one is slips and trips. The second one from bottom is falls from height, but the big one, far and away the biggest, is slips and trips. And that's why we take such an interest in good housekeeping and quality of floors and good lighting. When we're working at height, we think about a hierarchy of controls. What would our first choice be? Well, our first choice would be, don't work at height. If we can avoid working at height, we've protected everybody. But if we want to do the job, we're probably going to have to work at height. Can we reduce the amount of work at height or make it safe? Yes, we can. We can provide equipment like a cherry picker, or like a scissor lift, or like a mobile elevated working platform, a MUP, and that gives a safe working environment for somebody to stand on a platform with a handrail, lifted up by the machine to do the job, and then come safely down again. And if we can't do that, then we can make the distance that the person has to fall less. And I'll talk about that in a later slide. So first choice, don't work at height. Second choice, find a safe way to work at height. Third choice, make sure that the distance somebody falls is less. So risk factors for working at height. Risk factors are things that make it worse. So if you're falling from height, the distance that you fall makes a difference. So if you fall 1 meter, you're probably going to be okay. If you fall 3 meters, you're probably going to be injured. If you fall 7 meters, you're going to hospital at least. So the height makes a difference. The landing surface, what you land on, makes a difference. So if you land in water, you'll have a soft landing, and I hope you can swim. If you land on concrete, you're going to have a hard landing. But maybe even worse, if you land on steel reinforcing bars that are pointing upwards, you can be seriously injured. So the landing surface. Fragile roofs. I talked about those profile cement roofs. Over time, these lose their strength and become fragile. Fragile means easily broken. And you can fall through them, and people have done. Another risk factor is unprotected edges. So we have an edge, and then somebody could fall over the edge, so we put a handrail along that way to protect it. Another risk factor is poorly maintained access equipment. I have a cherry picker, it's going to lift me up, but if it doesn't work, or doesn't work correctly, I'm going to be injured, either when it drops or if I hit something. Another risk factor is the weather. Wind blowing people and equipment and materials, snow for slipping, dust for slipping on as well. These are all factors related to the weather and we need to know about the weather. And tower cranes, for example, are not to be operated above when the wind speed is more than, say, 40 kilometers an hour. And then falling materials. If something's falling, you're probably not looking up expecting it to run away, it'll just hit you. So falling materials are a problem. So for work at height, we need to have emergency plans. What happens if, on the top floor of a building under construction, someone is injured? How are you going to get them down? You need a plan. The plan may be, we call for help, people run up the stairs with a stretcher and carry him down. The plan may be the tower crane comes over with a special basket for carrying the injured person. But whatever the emergency plan is, we need to have the plan. And with that plan, the equipment, either the stretcher or the emergency basket for the tower crane. With the equipment, we need the emergency team, the people who are going to carry the stretcher, or the crane operator who's going to move the lifting basket and know where he's going to lift it down to for the ambulance. So the team need emergency training. This is how you're going to do it. This is how you'll carry him safely down the stairs. This is how the crane operator will lift you slowly and carefully and put you where the ambulance can get to. That's the emergency planning we need to plan. So some safety equipment for work at height. Fall nets. Fall nets are exactly what they say. So let's imagine that you have a steel frame building and you're going to put the roof sheets on it. Okay? So now to stop people falling while they're fixing the roof nets, you hang a net underneath the steel beams. If you hang the net, then they'll have to fall maybe 1.5 or 2 meters from the roof into the net, and they're caught safely. The net will give a bit of a movement, and they'll climb back up and carry on working. They will not have been injured. That's the point. So fall nets. Another opportunity is fall bags. These are bags rather like a bouncy castle, a children's bouncy castle. But let's suppose we're building a blockwork wall in a small house, and there's a risk of somebody falling on either side of the wall that we're building. So let's say we've got a scaffold on this side, but there's a possibility of somebody falling as they're laying the bricks. So on that side we might have this inflated bag, and the air pressure inside provides in effect a bouncy castle. But when the man falls, instead of a bouncy castle making him bounce, there's a valve to let the air out. So he falls onto the bag and the air comes out, so he lands smoothly and slowly and safely. We can have harnesses and lanyards. Harnesses are things tied round the person and hooked to something so that they're safe. If they fall, they're held up. If you have a harness, let's imagine someone climbs with a harness, climbs a big electric pylon. You need to have an emergency plan to get him down. So he falls, and he's now hanging. He's hanging from the lanyard and harness. This is good. He's safe. How are you going to get him down? You need to have an emergency plan to get him down. Otherwise, he's hanging there. And if you have a harness on and it's round your legs, as it should be, if you're hanging for 20 minutes or more, your blood from your heart will pump the blood into the person's legs, but it will not come back up because of the tight harness. And he will get suspension trauma and he can die in 20 minutes. So without the harness, he would die in 2 seconds, and with the harness, he will die in 20 minutes, unless you have an emergency plan in place to get him down. So think about the emergency plan with the harness. A fall arrest system is what I've just described. It's a harness and a lanyard and a system to catch somebody after they've fallen. A fall prevention system is a harness and lanyard, but it's tied to, let's say, a wire, so I cannot reach the edge. So if I fall on the roof, but I can't fall over the roof because it stops me falling over the roof, falling over the edge. So fall prevention. And then if we have these fall arrest or fall prevention systems, we need to have head protection, because when we fall, we might fall and bang our heads against the side of the building, and if we do that, then we'll be unconscious as well as hanging from the harness. So we need to have the complete package working together, and the emergency plan to get us down. There are many types of access equipment, ways to get up to something to do the job. Scaffolds. You will have seen scaffolds. These are working platforms made with poles and clamps and planks of wood. And if they're made correctly and they're designed correctly, they'll carry the load that you intend to put on them. But a scaffold will be made for a particular load. So it might be a load for the men and some tins of paint. That will not be as strong a scaffold, that is for the men and blocks of concrete that we're going to make into the wall. So the scaffold needs to be designed and constructed for the job that it's going to do. Mobile towers, I'll show you a picture of one in the next slide, but it's pieces of scaffolding that have been joined together, so we can just stand and fit them together to make the tower. And there are techniques for each manufacturer how to build that scaffold tower safely without the risk of yourself falling down while you're building it. So we have techniques to build mobile scaffold towers correctly and safely, so people will need training how to do that. Ladders. Ladders are a very useful tool, but they're only for short-term work. Don't expect someone to stand on a ladder all day, because his calf will get very tired and he's likely to fall. So for ladders, for short work and work you can do with one hand, because you need to have what we call 3 points of contact with a ladder. So you have 2 feet and 2 hands, that's 4 points. So I can move one hand and then hold with this one, then move this hand and hold with both hands, then lift one foot and then lift the other foot. I keep 3 points of contact to do the climbing, up and down, and to do the work I need 2 feet and 1 hand to hold the ladder, and I can do the job with 1 hand only with a ladder. Don't ask someone to do a job like drilling that needs 2 hands on a ladder, because he can fall. Step ladders are ladders like this, with steps on one side and a support on this side, and they have a tie piece across there so the ladder doesn't do that. The step ladder doesn't open. And again, you need to have 3 points of contact and one-handed work only, short-term work. Trestles are supports like this and then planks across the top so that you can stand on the planks. These are for low-level work, not for high work, just for low-level. And there's a danger that people will fall off trestles unless they have handrails. Mobile elevated working platforms, these are called MUPs for short. These are very useful tools. They provide a platform with a handrail and a door which you shut, and now you have a safe place to stand, and the platform will lift you up to do the work, and you can bring up with you the tools that you need, bring you up, and then lift you down safely. Stop. Well, this is a picture of safety access equipment, and this equipment is a mobile scaffold. And you'll see that it's been put together perhaps with 2 bars and a vertical as one piece. You'll see that it's got diagonals at the ground level, side supports, we call them rakers, to stop it falling over. You see it's got platforms for people to stand on and a handrail round them so they can get up onto the roof. I think they probably have to climb to get onto the roof, so I think for me the scaffold needs to come up another level. And then round the bottom they've got a barrier, so the public in this case don't walk too close to that scaffold tower. But that's an example. Okay, inspection equipment. We have the access equipment like MUPs, mobile elevated working platforms, man riding lifts, harnesses, fall arrests. These all need to be checked and maintained and stored and used as per the manufacturer's instructions. So just like for your car you have a car user's guide, there will be a guide for every piece of equipment and how to use it and store it and maintain it. So follow those instructions. A scaffold that's been put together with poles and clamps and planks of wood, that needs to be checked by a third party when it's first built. So when we've erected the scaffold, on erection, somebody else comes to check it. They say it's okay. Then every week, after a certain period of time, every week, we need to check it again. Check the clamps are still tight. Check that it's looking okay. Then if we want to change the scaffold, let's say we want to move a piece of the scaffold for some reason, because it's in the way, then when we change it, we have to get the third party in to check that the arrangements that we've made to change that scaffold are good ones. And the fourth reason is, if we have a high wind, or if a vehicle hits the scaffold, something has happened, potentially to damage the scaffold, then we need to get the scaffold checked again by a third party, a competent person. So scaffolds are great, but they need routine checking, and they need to be checked whenever there's a change or some reason to suspect it might have been damaged. Now, temporary works. Temporary works are whatever you need to do to make something, but that you don't need and you remove before you finish. So for an example, I want to build a building, I need a foundation. I have to dig a hole to make the foundation. That hole is a piece of temporary work, and holding up the sides of the excavation is a piece of temporary work. Or if I want to pour a concrete slab, I have some shuttering and some supports for the shuttering. That temporary shuttering is temporary works, and when we've finished and the concrete is gained its strength and is set properly, then we remove the temporary works. So temporary works are anything like that. It could be a piece of equipment. So I have a tower crane on site to help me move materials around the site. What's holding up the tower crane? A foundation. That foundation is a piece of temporary work. And the tower itself, tower crane itself, is a piece of temporary equipment. So these are all scaffolds, piece of temporary equipment. All examples of temporary works. Temporary works are important, and they need to be managed correctly. So it could be earthworks, trenches, excavations, temporary slopes, piles of soil. So if we excavate a big hole and we put all this soil here, that pile of soil is actually a piece of temporary work, because when we've finished, it will not be there. Cofferdams. Cofferdams are dams in a river or in the sea to keep the water out while we build, let's say, the foundation for a bridge. And when we've finished, we'll remove the cofferdam. It's become a temporary works. Formwork, false work, propping, facade retention, needling, all these terms are temporary things to hold up either the new structure or the old structure while we do the work. Temporary access bridges, even the signboards on a site are temporary works. The fencing around the outside of the site, temporary works. They all need to be managed correctly and to be safe while we do the work, safely erected, safely used, safely removed. And the foundations for the tower crane, anchors to hold things up, mobile elevated working platforms, crane and piling platforms, they're all important to us. And they're temporary works, and you need to put your good engineers on managing these, because people tend not to think about them enough. So they're temporary structures to help us do a job. So we have what we call a temporary works coordinator, and they will coordinate the design for the temporary works with the design for the permanent works to make sure they work together. So you may have a tower crane attached to the side of the building that you're building. So once this slab has, this bit of the frame has been constructed, you can use that to support the tower crane from being blown over. So that coordination of design is important, and the temporary works coordinator will do that coordination. You may have contractors in to do the temporary works. So you need to appoint those contractors, you need to choose ones who have experience, skills, equipment to do it, and the coordinator must manage that whole process and manage them doing the work, so the work that they do doesn't affect the people's safety doing the permanent works, and the people doing the permanent work doesn't affect the safety of the temporary works. The temporary works coordinator will supervise these temporary works, scaffolds, excavations, tower cranes. When it's complete, he will say so. He will give permission for you to put load on the temporary works. If it's a scaffold, the temporary works coordinator will say, yep, it's okay now for you to put your materials on it. And then he will say at the end, it's okay for you to dismantle and remove those temporary works. So the temporary works coordinator is an important job, particularly for safety and for the construction of the building itself. Without the temporary works, you will not have a building. Vehicle movement accidents. So, road traffic accidents do happen, and they can happen because of the driver error. Maybe he falls asleep, maybe he does a dangerous manoeuvre, because the vehicle fails, maybe the brakes fail, or because the driving environment is not safe. Maybe there's snow or ice in the UK, maybe there's a sandstorm in Oman. So for three reasons, driver error, vehicle malfunction, or the environment, the weather, all these things are potential reasons for road traffic accidents. They can also happen, accidents can also happen when the vehicle is not moving. The vehicle is parked and we're loading it. So we're either lifting things up with a forklift and something could be pushed down, or we're tipping it up with a tipper truck and it falls over, or we're tying the load. We have a flatbed lorry and we're throwing the straps over and the strap comes over and hits somebody on the other side. Or we've got the vehicle jacked up to do some maintenance and the jack slips. So these are all potential accidents when the vehicle is stationary, the vehicle is not moving. So traffic routes. The route that the vehicle takes, on-site or off-site, needs to be thought through carefully. We want it to be wide enough so the vehicle can safely go and make the turns and go around the corners and so on. If we can make it so it's one-way traffic, so you come in this side, go round and go out, that's best. If we have to reverse, then we need banksmen to help us. If we have to turn the vehicle round, we need a big turning area for the vehicle to turn, and we need to keep it clear so it's available for the vehicle to turn. It's not got used as a store area. Signposts. We can put signs to say speed limit. We can put signs to say pedestrians are here. We can put signs to say height limit. Junctions need to be clearly marked. So if this is a vehicle route and this is where people walk, we need to make a junction. We can do it with signs or traffic lights or even an operator to control it. And then we need to have space and a flat area for people to, so that trucks can park and be loaded or unloaded. Right, environmental considerations, severe weather. If it is raining heavily, you have the danger of slipping, you have the danger of water on the road for aquaplaning, so the tyres sort of come up onto the water and don't grip the road. If there's a sandstorm, you can't see where you're going, and the sand will make the road slippery, and you may even lose where the road is because it's covered in sand. If it's extremely cold, again, that can affect the braking system, it can affect the oil, it can affect your visibility. And fog especially will affect visibility. So what do we do to control it? We train our drivers. If it's raining, slow down. If it's raining really heavily, find a safe place to park. Make a phone call to say you're going to be later and wait for the rain to stop. And same for sandstorms. And if we have training, then we can also have policies that say to our drivers, this is what you do if the weather is bad. And if, as a driver, you have any doubt in your mind that it's safe, it's not safe, don't drive. Just don't do it. Park and wait till it's safe. Vehicles should be fit for purpose for maintenance. Okay, so we have to maintain our vehicles. You have a car probably. You maintain the car, or if you don't maintain it, you get somebody else to do it. Now with any piece of equipment like a car or like an excavator, you'll have daily checks. So you might check the tyres or you might check the oil daily. You'll have weekly checks. for other things. You'll have routine servicing with your car every 5,000 kilometres. You do routine servicing. And then you need a procedure that if the driver says, I think there's something wrong with this, you have a system for him to report it and for a mechanic, a competent person, to check that what he's saying is correct or not correct, but to sort out the problem. So vehicle maintenance is essential. So to manage work-related road risk, we need a policy. The policy might be, we have in-vehicle management systems. These are GPS, global positioning system devices attached to the vehicle and can tell the operator of the system how fast you are going, whether you're accelerating rapidly or braking harshly, and they can give a report, a continuous, in real-time report to the manager of how you're driving. You can plan the journey. If I'm planning to send somebody a long way to, let's say, Salalah, I need to plan the journey. He's going to need to have brakes. Maybe I need 2 drivers so they can have a break and change. They'll probably have to park up overnight. They need somewhere to stay, a safe place to park the lorry where nothing will get stolen from it. That kind of thinking needs to be part of the journey management. The drivers will need training. I have a license that lets me drive a car, a light transport vehicle. I am not licensed to drive a heavy vehicle. So don't let me drive your heavy vehicles. Check that your drivers have the right license for that particular piece of equipment. So the truck driver is good for the trucks, but he's not qualified to drive an excavator. You need an excavator license for the excavator. You need the right license for the particular piece of equipment. And then the driver needs to be fit and healthy. The things that you need to be alert for particularly: has the driver had his eyes checked recently? Has he got diabetes? Is he managing the diabetes well? Is his heart condition good and strong? These are things that you can check and have as part of your policy to say, we have a policy and we'll manage our drivers this way and keep them safe. So, keeping on the topic of managing road risk, vehicles, are they suitable for the job? If you have a 4x4 pickup, you cannot put a 10-ton load in it. It's too heavy. So you need a suitable truck, in this case a truck with a 10-ton capacity. You need to inspect your vehicles regularly. The driver can do a routine check, but you need to check that routinely and regularly that the vehicle is safe and roadworthy. It's in a good condition, ready to use. And then we're going to plan the journeys, the distance and the time. We're going to schedule it. Maybe we have to drive into a city. We don't want to drive our trucks into the city when there's lots of school children around. So we might schedule our deliveries either for before school starts or during school or after school, but not when the kids are coming in and out of school. We'll schedule rest periods so our drivers are in good condition, they're not fatigued, not too tired when they drive. And then we can have reporting and monitoring. So any concerns that the driver has, he has a mechanism to report it, and he can be confident that that report will be checked and the vehicle will be in good condition when he picks it up to drive it. Right, hazards from workplace transport. Well, one obvious hazard is vehicles can have collisions with each other. People can fall off vehicles. If they're tying loads or tying sheets on tops of trucks, there's the risk of falling off. If people can fall off, things can fall off onto people. You can overload the truck. You may have seen pictures on YouTube or other places where trucks and vehicles are overloaded. They're obviously carrying too much. If the driver has so much material and he can't see in his mirrors, there's too much on that truck. Another hazard is vehicles overturning, either because they're going around a corner too fast or because the driver goes to sleep a bit and makes a sudden turn with the wheel. there can be communication problems between the drivers and the vehicle and pedestrians. So if the truck driver comes to the gate of a complex and he has to shout down at the guard, not good communication. Better to have the guardhouse elevated so the window of the guardhouse is on the same level as the window of the truck. Then they can both open their windows, have the conversation and carry on. Lack of barriers and signs. If we come into a factory complex, we want there to be barriers that say, don't go down that way, it's a dead end, turn right. Or we want signs that say, be careful, the overhead gantry, the overhead bridge here is only 5 meters tall, and I know how high my truck is, so I won't go down that road. We can have speed limits as well. Then we need to have training for our drivers. They need to be competent. They need to know how to drive this vehicle in this environment. And then they need to know also what to do if there's a fire. There's a high risk of fire when you're refueling, for example. So you can have procedures and checklists so that drivers know how to manage the refueling of their trucks and make some checks. They might check all the tyres and then check the fuel cap is back on securely before they drive off. So have in places controls for these transport hazards. So controls that we might have include choosing the route, making sure there's no low bridges that way, for example. Signs, speed limits. You can set speed limiters on the vehicles themselves. So you can say, right, my car, for example, if I go to 120 kilometers an hour, starts making a noise. Beep, 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 beep. So I know I'm going too fast, so I slow down. Have one-way systems. You can have a separate one-way in and another way out, and then you'll avoid vehicles having to pass each other. Manage your exit routes. Site rules are things like the site speed limit is this much. On site, if you get out of your truck, you must be wearing a yellow vest so that we can see you. Those are site rules. The environment, we can manage the environment of our complex by having good lighting, particularly at the junctions or where people might be walking. We can choose the road surface. Make sure the road surface is not slippery. Make sure it's not sloping steeply. If the road changes level, there's a step in the road, there's a bump, that's bad for our trucks, bad for our vehicles. So let's make them smooth. We can have an induction training. If you're going to drive on our complex, you need to have this training. And an example of that would be, if you drive on PDO land in Oman, then you need to have a PDO driving license. And that will have taken you through these controls about how to park, where to park, what hazards there are, and how to manage them. And then the drivers need training in these things. How to tie their loads, how heavy the loads can be, how to drive safely, when to take rests. All these things can be part of their training. For the vehicles, we need to keep records. Suppose you have a vehicle and you keep the records, and you notice that whenever Jonathan drives it, there's always a problem with the brakes afterwards. You'll know that the problem is not the vehicle, the problem is Jonathan, the driver. So keep maintenance records, and if you have a consistent or recurring problem with something, get it checked and fixed properly before an accident happens. And that will mean having test certificates and good record keeping and thinking about and reviewing the records. Have a policy that says wear seat belts. It's the law in Oman and in many countries, but make sure your people are wearing them. You can have devices to stop things falling off the lorries. You can have rollover bars inside the vehicle, so that if the vehicle does roll over, we hope it doesn't, but if it does, the person inside the vehicle is not crushed because the rollover bars kept the car up and he's in that safe cage, the safe space inside the rollover bar. Minimise reversing. If you're reversing, you can't really see where you're going. So if you have to reverse, have warning signs, have cameras on the back of the truck, have a banksman to tell him it's all clear. Have a system in place to manage reversing if you have to reverse. If you can avoid reversing, avoid it. and then try to minimise climbing. If people have to go up, we talked about falls from height earlier, then it's difficult for them to do that, and it's more likely they'll fall. But you will have seen trucks that have a bar, and you can pull the bar, and the bar pulls the sheet pulls the load over the back of the truck to stop dust and things falling off. And the person moves that bar from the ground level, so he doesn't have to climb. So they eliminated the need to climb by good design of the vehicle. And finally, just to say thank you, and please follow us on Instagram or Twitter or LinkedIn or Facebook. Thank you.